Trigonometry has a reputation problem. Triangles, circles, endless waves, it looks like three different subjects wearing one name badge. So here is the secret up front. It is all one idea. A point walks around a circle, you film its height from the side, and out comes this wave. In this unit you meet the three famous ratios, collect the exact values examiners adore, stretch and shift the graphs, master exactly two identities, and learn to hunt down every solution of a trig equation, without the classic mistake of finding one and going home early. Let's map it out. Everything starts with a right-angled triangle. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Generations of students have survived on one magic word, so, ka, toa. Say it like a sneeze, write it on every page. One more family secret before we move on, tan is just sine divided by cos. That explains its personality. Wherever cos hits zero, tan is forced to divide by it and storms off to infinity. It does this every 180 degrees. Keep an eye on it. Paper 1 bans your calculator, so a small set of exact values becomes hard currency. 30, 45, and 60 degrees. The good news, you never memorize a table. You rebuild it from two tiny doodles, half a square and half an equilateral triangle. Label the sides, read the ratios straight off. Sine of 30 is 1/2. Tan of 45 is exactly 1. Sine of 60 is root 3 over 2. Root 3 appears precisely where everyone forgets it. Two doodles replace a whole table, and your exam hall self says thank you. Now the graphs. Sine starts at 0, cos starts at 1, otherwise they are the same wave wearing different starting positions, 90 degrees apart. Both live forever between -1 and 1, and both repeat every 360 degrees. Nothing new ever happens, that is the point. Tan refuses to join the club. No ceiling, no flaw, and a vertical asymptote every 180 degrees, where it blasts off to infinity, flips sine, and pretends nothing happened. Sketch one branch between the asymptotes, then copy and paste it forever. The exam loves dressing these waves up as a sign of bx plus c. Three dials. A stretches the height, B squeezes more cycles in, C lifts the whole wave off the floor. Twist one dial at a time when you sketch, and no costume will fool you. Pure 1 needs exactly two identities. Tan equals sine over cos, which you already met. And sine squared plus cos squared equals 1, an identity so reliable it should be paying rent in your working. Together they convert almost any trig expression into any other. Here is the move you will repeat for 2 years. Spot a sine squared, swap it for 1 minus cos squared, and a messy trig equation quietly turns into a quadratic in disguise, and you already know how to hunt quadratics from Unit 1. Same prey, new camouflage. Solve sine of x equals 1/2 between 0 and 360. Your calculator instantly says 30 degrees and then acts like the job is done. It is not done. Look at the wave. It crosses 1/2 twice every cycle at 30 and again at 150. Every single year, somebody finds one solution and goes home early, and somewhere a mock scheme weeps. So, take the calculator angle, find its twin across the wave, then sweep the whole interval for repeats. And read whether the question speaks degrees or radians before writing anything at all. Here is the entire unit as one poster. The skeleton, one wave repeating forever, three ratios that read the triangle, and two identities that let you rewrite anything. If you can redraw this page from memory, you own the theory side of trigonometry. When equations show up, run the drill. Calculator angle, twin angle, sweep the interval. That one habit, plus the two doodle triangles for exact values, quietly carries most of the trig mocks in paper 1. Boring, repeatable, devastatingly effective. And finally, the boundary fence so you do not over-revise. Sec, cosec, and cot, compound angles are form, all real, all examined later in pure 2 and 3. If a formula book page looks terrifying, check the unit number before you panic. For now, this page is the whole game.